There are a lot of unusual questions regarding our universe, and these questions, of course, can start with what is the universe? Number one. Number two, how did the universe begin? Number three, what is in the universe? And number four, what are dark matter and dark energy? Because we can only see about 5% of the universe directly. Now there are a lot of unusual questions. Basically, we are trying to have a basic guide to our universe. So let's start with what is the universe? The universe is everything that exists, from the smallest particles to the largest structures like galaxies. It includes all matter, energy, space and time. How did the universe begin? The most widely accepted theory is the Big Bang theory, of course. About 13.8 billion years ago, the universe began as an incredibly hot, dense point that expanded rapidly. Now let me have a little bit knowledge about this Big Bang theory, right? What is this Big Bang theory? Okay, the Big Bang is the prevailing cosmological model that explains the early development of the universe. It posts that universe originated from an extremely hot and dense state approximately 13.8 billion years ago and has been expanding ever since. Now what are the evidences supporting this Big Bang theory? Number one is cosmic microwave background, or CMB. This is a faint radiation that fills the universe, considered the afterglow of the Big Bang. Number two is redshift of galaxies. The observation that galaxies are moving away from us at a rate proportional to their distance. And number three is abundance of light elements. The observed abundance of elements like hydrogen and helium aligns with predictions of the Big Bang model. Now, of course, you might wonder, why only the Big Bang theory? Why not there are other theories about this creation of this universe? Yes, there are, but most of them are discredited. While the Big Bang is the most widely accepted theory, there have been alternative proposals. Number one is steady state theory. That means this theory suggests that the universe has always existed and will continue to exist, with matter continuously being created to maintain a constant density. However, evidence from the CMB and the expanding universe has largely disproved this theory. Number two, oscillating universe theory. This theory proposes that the universe undergoes cycles of expansion and contraction, with each cycle representing a new Big Bang. While this idea was once considered, it has faced challenges due to the observed acceleration of the universe's expansion. Now it's important to note that while the Big Bang is the most supported theory, there are still unanswered questions about the universe's origin and its ultimate fate. Scientists continue to explore and refine our understanding of the cosmos. Now let's come to another unusual question. What is in the universe? In this universe, there are, of course, galaxies. What are galaxies? Massive collections of stars, gas and dust held together by gravity. Our Milky Way is just one of billions. I am coming to this point in a minute. That means what is galaxy and what is Milky Way. Don't worry. Now, in this universe there are also stars. Like our sun is of course a star, are giant balls of hot gas that produce light and heat through nuclear fusion. There are planets, objects that orbit stars. Those are called planets. Earth is one of the 8 planets in our solar system. Other stuff, there are also moons, asteroids, comets, black holes, and much more. We'll come to that point, much more. That means what are there in that much more category. I'm coming to that point in a minute. Before that, let me talk about dark matter and dark energy. What are dark matter and dark energy? The point is, we can only see about 5% of the universe directly. The rest 95% we cannot see. So most of the universe is made up of mysterious substances called dark matter and dark energy that we cannot see. We don't fully understand them yet, but they play a crucial role in the universe's structure and expansion. Not every star has a solar system like ours, of course. Now come to the stars. While it's estimated that a significant number of stars have planets orbiting them, it's not a guarantee for every star. Why? Because factors that influence whether a star has planets, there are a lot of factors. Okay. Sorry. And I'm here telling you 3 of them, most important 3 factors. Number 1 is stellar mass. Stars with lower mass, like red dwarfs, are more likely to have planets. Metallicity. The presence of heavier elements in a star can influence planet formation. And number 3 is stellar age. That means older stars may have less material for planet formation. Sun is young, right? While we have discovered thousands of exoplanets, our understanding of planetary systems is still evolving. As technology advances, we will likely discover even more diverse and fascinating planetary systems around different types of stars. But we have to wait for that, for more advanced technology to come. Now, I just said that not every star has a solar system like ours, isn't it? While it's estimated that a significant number of stars have planets orbiting them, it's not a guarantee for every star will have planets like beautiful planets like us. And I told you about the factors that influence why a star has planet or not. Now come to that much more thing. That means we have just said that in universe there are moons, asteroids, comets, black holes, and much more. What is in that much more category, right? So the much more in the universe includes a wide range of celestial objects and phenomena. First of all, we call nebula, vast clouds of gas and dust, some of which give birth to stars and planets. Pulsars, rapidly rotating neutron stars that emit beams of electromagnetic radiation. Quasars, extremely luminous objects powered by supermassive black holes at the centers of galaxies. And of course, dark matter and dark energy, mysterious substances that make up most of the universe's mass and energy, of which only 5% we can see, and of which 95% we cannot see. Exoplanets, planets orbiting stars other than our sun. That means there are billions of galaxies, billions of solar systems. So there could be billions of planets, isn't it? Possibility of having planets. So they are called exoplanets. Now there are dwarf planets, smaller celestial bodies like Pluto, Ceres and Eris, that orbit the sun but haven't cleared their orbital path of other debris. Interplanetary dust, that means tiny particles of rock, very small rock, and ice that fill the space between planets. Cosmic rays, high energy particles, often originating from distant galaxies that constantly bombard our Earth's atmosphere. And supernova remnants, the expanding debris clouds that left behind by massive stars after they explode. And many more. Still there are many more. So that is not the end of this much more category. There are many more. The universe is filled with incredibly diversity and wonder, and scientists are constantly discovering new and fascinating objects. So, thing is, the universe operates on a set of fundamental laws, right? Primarily governed by physics. So, if you really want to understand universe, you need to study physics. That should be your starting point. Okay. Here are some of the most important ones. If we talk about those laws that govern our universe, laws of motion. These are called physical laws. Of course, they are related to physics. Laws of motion. These laws, formulated by Isaac Newton, describe the motion of objects. They include the law of inertia, the law of acceleration, and the law of action and reaction. Law of universal gravitation. This law explains the force of attraction between any two objects with mass. That means two objects always attract each other. Large objects always attract small objects to it. Laws of thermodynamics. These laws govern the behavior of heat and energy. They include the law of conservation of energy, which states that energy cannot be created or destroyed, only transformed. Laws of electromagnetism. These laws describe the behavior of electric and magnetic fields. And of course, theory of relativity. This theory, developed by, Albert Einstein, explains the relationship between space, time, gravity, and the speed of light. Other fundamental principles include conservation laws. These laws state that certain quantities such as energy, momentum, and angular momentum remain constant in a closed system. And there is, of course, quantum mechanics. This theory explains the behavior of matter and energy of the atomic and subatomic level. You can call it microphysics, isn't it? Something very small, not big as galaxies. It's important to note that these laws are based on our current understanding of the universe and may be subject to revision as we learn more. Additionally, some people believe in more metaphysical or spiritual laws that govern the universe, such as the law of attraction or the law of karma. Now, the question is whether the universe is expanding or shrinking. Okay, the answer is universe is expanding, because astronomical observations have shown that galaxies are moving away from each other at an increasing rate. This expansion is driven by a mysterious force known as dark energy. It's important to note that this expansion isn't like a balloon expanding into a pre-existing space. Rather, it's the fabric of space-time itself that is stretching. So, our last unusual question is the universe infinite or it will die? The answer is we don't know so far. At least for sure we don't know. The observable universe is vast, but it might be just a tiny part of a much larger, possibly infinite universe. So the key points to remember is the universe is incredibly old and vast. We are still learning a lot about it, and we don't know in fact 95% of it, so to say. Our understanding of the universe is always evolving. Here comes the concept of multiverse. That means more than one universe. Since we are accepting this theory that universe is expanding, universe is stretching, etc., etc., So there could be another universe that we cannot see still now, that belongs to that 95% of the unseen factors. The concept of a multiverse, a collection of multiple universes, is a fascinating topic that has been explored in both science fiction, theoretical physics, and of course, if you are a cinebuff, then you know that there are multiverse cinemas also. So, while there is no definitive proof of its existence, some theories suggest the possibility of other universes with different physical laws and constants. There are possibilities. Okay. Now here are a few theories. Since I am talking about multiverse, so I need to give you some theories also. Possible few theories that support the idea of multiverse is eternal inflation. The theory suggests that our universe is just one bubble in a vast cosmic foam, with countless other bubbles representing different universes. Okay, string theory. It's very important because this theory proposes that our universe exists in a higher dimensional space and other universes could exist in different dimensions or planes. Many worlds interpretation of quantum mechanics. This interpretation suggests that every quantum event creates multiple universes, each representing a different possible outcome. Now, these theories are intriguing. It's important to note that they are highly speculative and have been experimentally verified. The existence of other universes remains a subject of ongoing debate and research. So the ultimate fate of the universe, whether the universe will die or not, will not exist anymore or not, cease to exist, etc. The ultimate fate of this universe, at least our universe, is a complex question and with several possible scenarios. Depending on various factors like the amount of dark energy and the geometry of the universe, here are the main possibilities. Still, we can discuss about the possibilities. Number one is heat death, which we also call big freeze. This is the most likely scenario given our current understanding of the universe. As the universe continues to expand, galaxies will move further apart and apart and apart, and eventually stars will burn out. The universe will become increasingly cold and dark, and all matter will eventually decay into radiation. Second theory is Big Rip. If dark energy continues to accelerate the expansion of the universe at an increasing rate, that means galaxies are running away from each other, it would eventually overcome the gravitational forces holding galaxies, stars, and even atoms together. This would lead to a catastrophic event where everything in the universe is torn apart. And third in this theory category is Big Crunch. If there is enough matter in the universe, gravity could eventually overcome the expansion, causing the universe to collapse back in itself. This would lead to a reverse of Big Bang, potentially leading to a newer cycle of expansion and contraction. Now, let me tell you the last thing, that it's very important to note that these are just theories, okay, and our understanding of the universe is constantly evolving. As we gather more data and refine our models, we may gain a clearer picture of the universe's ultimate fate. I hope you get at least an idea about our universe in a nutshell. Not a very good idea, of course. There are still more to come. There are still more to understand. But at least we have covered a few things, few important things that we might cover in the future in a detailed way. Of course, we will cover in the future. Hopefully, it gives you an idea about our universe and all the possibilities and all the possible theories and everything about it. So that is it today from me. See you in the next video. Till then, goodbye and take care and stay safe.